To find the critical points, we need to take the derivative of our formula for the area. It starts off relatively easy. The derivative of sine is cosine. We'll have to use the product rule on sine times cosine. Once again, derivative of sine is cosine. Derivative of cosine is negative sine. And when we clean all that up, we get this wonderful expression, which regrettably involves both cosine and sine. That's not so obvious to figure out how we're going to determine where it's equal to 0. However, using the classic trick that sine squared is 1 minus cosine squared, or sine squared plus cosine squared is 1, we find we can get an expression involving only cosine of theta. To determine where this equals 0, we're going to treat it as if it was a quadratic function, where instead of an x squared we have cosine squared, and instead of an x we have a cosine. So we're going to treat this just like it was 2x squared plus x minus 1. And as we work at factoring this, we see that's just 2 cosine minus 1 times the quantity cosine plus 1. Setting this expression equal to 0, we see either that 2 cosine theta minus 1 is 0, which means that cosine theta is a half, or cosine theta is minus 1. Among the numbers we're looking at, angles between 0 and pi halves, the only value that solves cosine theta equals a half is theta equals pi thirds. And in fact, there are no angles that satisfy cosine theta equals minus 1 in this restricted domain. So the critical point is that theta equals pi thirds, which of course doesn't actually answer the question. We need to know what the area is when theta is pi thirds. That's a matter of plugging pi thirds into our expression and solving. I will let you do that work. And I'll also let you make sure that what we found corresponds to a maximum value for the area of the trapezoid, which is a cross-section of the gutter we made.